We would like to be able to take a story about an object moving and map out the events on a map of the region it's moving through and mark the events on a timeline, and then really combine these two graphics into a single graphic, a graph of the object's position versus time. Our story is about young Ophelia, who has gone mad and is dashing about Castle Elsinore, wailing and moping and generally being melodramatic. The setting is the Grand Hall of Castle Elsinore, laid out here in glorious one dimension. Here's the entrance door to the hall, and that'll be our reference point for space. Our reference point for time will be the moment Hamlet enters this door. So we set time to 0, set our clocks to 0 when Prince Hamlet enters. At that moment, Ophelia is located here, 8 meters in the negative x direction. She doesn't notice Hamlet at first. Let's call this event A. Hamlet walks in. We'll mark on our timeline t equals 0. That is event A. She doesn't notice him at first. It takes 2 seconds before she does. And as soon as she does, we have event B. Ophelia notices Hamlet, and she starts wandering away from him in the negative x direction. She moves 4 meters this way. So, event B, she starts moving away. Oh, event B is here, 2 seconds after Hamlet walks in. She wanders this way until she notices the ghost of Hamlet's father, and she stops dead in her tracks and is frozen in terror for 1 second. Then she begins to flee. So let's call event C when she notices the ghost, and event D when she starts running in the opposite direction. She dashes at top speed across the Grand Hall, screaming, flailing her arms, getting her hair in her face, and not noticing the pillar over here at 12 meters, which she smacks into and comes to a dead stop once again. That'll be event E. Ophelia hits the pillar. She's moving pretty fast. It takes her 3 seconds to cross the hallway, so there's event E on our timeline, 3 seconds after she starts running. She's dazed for 2 seconds, and then event F starts wandering back towards Hamlet. He thinks that she's going to come into his arms, but she walks right past him and comes to a stop somewhere over here, and he doesn't know what's up with this crazy girl. So, event G, she passes up Hamlet and comes to a stop 4 meters over there. Okay, that takes her 4 seconds to walk across the room. So, event G occurs right there. Alright, so we've taken this story and mapped out the motion and marked these events on a timeline. Now let's combine all this into a single graphic that's easier to understand and to use. A position versus time graph. Alright, so at time equals 0, Ophelia is standing here, and we know that she doesn't move for 2 seconds. From A to B, she's standing still. Her position is constant, -8 meters. So here our map is sort of tilted vertically. Here's the door, and she is at -8 meters for the first 2 seconds. So for 2 seconds, she is located at -8 meters. From events A, Hamlet walks in, to B, she starts moving away from him. Now from B to C, she's moving away from him. She moves from a position of -8 meters to -12 meters, and it takes her how long to do it? 2 seconds. So in 2 seconds, she moves from -8 meters to -12 meters. So we'll have her sort of accelerate in the negative x direction, start moving, and then come to a halt. Right there, event C, she sees the ghost. She's now at negative 12 meters. She stands still for 2 seconds, or was it? 1 second here. 1 second from C to D. She's stunned when she sees the ghost for 1 second. She remains still. I'm using red because she is stopped, green when she is going. Event D, she shrieks and starts to dash across the room. How far does she go? From negative 12 all the way up to 12. So she's going to go from negative 12 all the way to 12. And it's going to take her 3 seconds to do it. From D to E, 3 seconds. So in these 3 seconds, she's going from negative 12 all the way up to 12. So let's mark her ending point. 3 seconds later, she's going to be at 12 meters. Okay, so let's have her accelerate. She's running, and comes to a halt when she smacks into that pillar, event E. She's stunned for 2 seconds, so she remains still. Her position is not changing with time. She's at 12 meters for these whole 2 seconds while she's still. Then event F, she starts going back towards Hamlet, and it's going to take her from F to G 4 seconds to go from 12 to negative 4. So in 4 seconds, she's going to go from 12 to negative 4. So 4 seconds later, she's at negative 4. Let's show her accelerating in the negative x direction, moving in the negative x direction, and reaching that point. So the end of our story here is G. All right. So let's look at the features of the graph here. Notice that when the line is horizontal, that's indicating that she is not moving. Her position is constant with time, not moving for these horizontal portions of the motion. When we've got sort of a line with roughly kind of a negative slope here, she's moving in the negative x direction. Moving in the negative x direction from F to G and from B to C. But from D to E, she's moving in the positive x direction. Her position is getting more positive with time. All right, let's try interpreting another motion graph. Okay, here's some other object's motion. And I've marked different events here. And I want you to tell me between which pairs of events is this object moving in the positive x direction, between which pairs of events is it moving in the negative x direction, and between which pairs of events is this object not moving. Pause the video for a moment, think about it. Ready?